In our previous lesson, we discussed the Riemann sum, and we have seen how the area of plane region was defined as the limit of a Riemann sum. We also know that the limit of the Riemann sum is a definite integral. And by the second part of the fundamental theorem of calculus, it showed us a technique for computing the definite integral using antiderivatives. So now we will discuss how to compute the area, yung area talaga, hindi na yung net area under a curve. So let's take a look at this example. Let's find the area of the region bounded by the curve y equals x squared plus 1, both axes and the line x equals 2. So first thing is, we have to visualize ano yung itsura ng area natin. So for our solution, ito yung itsura ng ating area. So this is the x squared plus 1 equals y na curve. This is our axis. And this is our line x equals 2. So, naglagay ako dito ng rectangle to show the Riemann sum. So the width of this is, we know that that is delta x, while the height is f of x sub I. So that is x sub I squared plus 1. So if we get the Riemann sum using this length and width, we have the summation from I equals 1 to n of x sub 1 squared plus 1 times delta x. And we know that the area is equal to the limit as delta x approaches 0 of the summation from I equals 1 to n of x sub I squared plus 1 times delta x. By FTC2, we know that the area is equal to the definite integral from 0 to 2 of x squared plus 1 dx. So, taking the antiderivative of x squared plus 1, that is x cubed over 3 plus x, evaluated from 0 to 2. Then, by FTC2, we now have 2 cubed over 3 plus 2. So, nilagay lang natin yung 2 dito sa mga x. Minus, evaluate natin sa 0, we have 0 cubed over 3 plus 0. Or that is now equal to 8 over 3 plus 2. Siyempre ito, 0 na lang yan. Or that is 14 over 3, or approximately equal to 4.67 squared units. Let's find the area of the region bounded by the parabola y equals x squared minus 6x plus 5, the x-axis, and the lines x equals 2 and x equals 3. So for our solution, again, we visualize ano ba yung itsura ng area na yan. So this is our curve y equals x squared minus 6x plus 5. Then we have the x-axis and the lines 2 and 3. Now this rectangle here has width equals delta x, and syempre ang kanyang length is x sub I squared minus 6x sub I plus 5. So, pansinin niyo na ito ay area sa baba. Okay? The area is below the x-axis. And we know that the resulting area will give us a negative area. But since area yung hinahanap natin, and area is always positive, so, etong length niya, okay, ini-negative natin ngayon. Kasi pababa siya so negative yan. So, ini-negative natin para negative ito, times negative, positive na siya, yung delta x natin is positive, para buong ito is maging positive. So the area now is equal to the limit as delta x approaches 0 of the summation from I equals 1 to n of negative x sub I squared minus 6 times x sub I plus 5 times delta x. That is the definite integral from 2 to 3 of negative of x squared minus 6x plus 5 dx. Then, by properties of definite integral, pwede natin ilabas yung negative sign. So, we have the negative of the definite integral from 2 to 3 of x squared minus 6x plus 5 dx. Okay, so makikita ninyo dito na actually, kapag negative pala yung area natin or nasa baba ng x-axis, we can actually evaluate that ng parang yung usual na ginagawa natin. Pero at this time, nilalagyan natin siya ng negative para yung negative na area maging positive. So now, if we evaluate that, the antiderivative of x squared minus 6x plus 5 is x cubed over 3 minus 6 times x squared over 2 plus 5x. Then don't forget the negative sign. Evaluated from 2 to 3. Simplifying, we have negative x cubed over 3 plus 3x squared minus 5x. Evaluated from 2 to 3. All that is now, evaluate na natin ito sa 3. So we have negative 3 cubed over 3 plus 3 times 3 squared minus 5 times 3 minus, evaluate naman natin sa 2, we have negative 2 cubed over 3 plus 3 times 2 squared minus 5 times 2. All that is now negative 27 over 3 plus 27 minus 15 minus negative 8 over 3 plus 12 minus 10. Simplifying, we have 11 now over 3, or approximately equal to 3.67 squared units. Let's find the area of the region bounded by the curve y equals x cubed minus x squared minus 9x plus 9, the x-axis and the lines x equals negative 2 and x equals 2. So for our solution, i-visualize uli natin. So by the graph, meron tayong area sa taas, tapos area sa baba. So we know that itong area sa baba, pwede natin kunin ito by taking the negative of the definite integral. Pwede natin kunin yung definite integral from negative 2 to that point, and then that point to 2. Tapos kunin natin yung sum ng dalawang area na yon. But, paano natin malalaman kung nasaan yung point na yon? In the graph, para siyang nasa 1. But we have to make sure that this is really 1. So to do that, kunin natin ngayon yung intersection nitong curve na to at itong line na to. And we know that the x-axis has a equation y equals 0. So we have these two, and we shall take the intersection of that by equating y equals y, or x cubed minus x squared minus 9x plus 9 equals 0. Then, if we factor that out, the factors are x minus 1, x minus 3, and x plus 3 equals 0. Therefore, we have values of x equal to 1, equal to 3, and equal to negative 3. Pero sabi niya dito, yung area na hinahanap natin is from negative 2 to 2 only. So, hindi nakasali si 3 kasi sobra na, hindi na rin kasali. And obviously, sa 1 nga talaga siya nagpa-pass through, or yun yung kanilang intersection. Therefore, pwede natin kunin ngayon yung area from negative 2 to 1, and then from 1 to 2. So that is, area is equal to the definite integral from negative 2 to 1 of x cubed minus x squared minus 9x plus 9 dx plus the definite integral from 1 to 2 of negative x cubed minus x squared minus 9x plus 9. Naglagay tayo ng negative dito kasi nasa baba yung ating area. Or pag nilabas natin yung negative dyan, we have the definite integral from negative 2 to 1 of x cubed minus x squared minus 9x plus 9 dx minus the definite integral from 1 to 2 of x cubed minus x squared minus 9x plus 9 dx. Okay, unahin muna natin ito. Ano nga ba itong value ng definite integral na ito? So we know that the antiderivative of this is x raised to 4 over 4 minus x cubed over 3 minus 9x squared plus 9x, and then we evaluate that from negative 2 to 1, or that is 1 raised to 4 over 4 minus 1 cubed over 3 minus 9 times 1 squared over 2 plus 9 times 1 minus negative 2 raised to 4 over 4 minus negative 2 cubed over 3 minus 9 times negative 2 squared over 2 plus 9 times negative 2. So you can verify that in your calculator that the value is 135 over 4. Sunod naman natin ito. So we have same yung kanilang antiderivative. So that is x raised to 4 over 4 minus x cubed over 3 minus 9x squared over 2 plus 9x evaluated from 1 to 2. Or that is 2 raised to 4 over 4 minus 2 cubed over 3 minus 9 squared over 2 plus 9 times 2 minus 1 raised to 4 over 4 minus 1 cubed over 3 minus 9 times 1 squared over 2 plus 9 times 1. And you can verify in your calculator that the value is negative 37 over 12. So now we know that etong definite integral na to is 135 over 4. Etong definite integral naman na to is negative 37 over 2. So we now have 135 over 4 minus negative 37 over 2, or that is 221 over 6, or approximately 36.83 squared units.